Fire alarm systems give critical early warning of a fire or smoke condition, enabling people to react quickly and evacuate safely. Today's computerized alarm systems are integrated with many other building components, such as air handling and venting systems, fire doors and elevators. But the basic function is the same: to detect smoke, fire, or water flow in a sprinkler system and send an alarm to occupants and to those who can take action. At its most basic, a fire alarm system consists of an initiating device, such as a smoke detector, heat or flame detector, or a water flow device. When activated, the device sends a signal to a control unit, which activates notification appliances that alert occupants and trained response personnel. All of these system components can fail. Therefore, they must all be inspected and tested on a regular basis. In this program, we'll show you some of the inspections and tests that are required by NFPA 72, National Fire Alarm Code. But first, let's look at each of the components of a fire alarm system: initiating devices, control units, and notification appliances. An initiating device is any component that provides an incoming signal to the fire alarm control unit. It may be a smoke detector on the ceiling, a beam detector in an atrium, or a heat detector in a machine room. A heat detector is an initiating device which either activates at a certain temperature, a fixed temperature type, or responds to the rate of temperature change, a rate of rise type. A line-type heat detector senses temperature change anywhere along its entire length and is used in such locations as cable trays. Radiant energy detectors, also called flame detectors or spark ember detectors, are sensitive to radiant energy in the ultraviolet or infrared spectrums, or both. This type of initiating device is typically used in hazardous industrial settings. Water flow devices send a signal to the fire alarm control unit when water begins to flow in an automatic sprinkler system, a sign that a sprinkler head has activated. Other types of fire suppression systems will also send a signal to the control unit when activated. A manual fire alarm box is also a type of initiating device. Sometimes these have protective covers to prevent accidental activation. So far, we've been talking about alarm signals which indicate a condition serious enough to warrant a fire department response. But initiating devices send other types of signals as well. Supervisory signals indicate that one of the fire protection systems is not in its normal state. Examples include a closed valve that should be open, a drop of air pressure in a dry pipe valve, or an electric fire pump power interruption. Trouble signals indicate problems such as loss of primary power, or an electrical problem such as a ground fault. The control unit is the nerve center of the fire alarm system, where incoming signals from initiating devices are processed. The control unit indicates whether a signal is an alarm, supervisory, or trouble signal, as well as where the signal originated.
Main entrance lobby.
If the control unit is located remotely, an annunciator panel will often be located near the entrance to guide response personnel to the problem. Older systems may indicate a zone rather than a specific initiating device. The control unit may also transmit signals off-premises, activate local alarm notification appliances, provide voice communication capabilities, activate fire suppression systems, and integrate with other building systems such as door closers and air vents. Notification appliances are designed to alert building occupants and others of a fire alarm condition. The alarm is usually a combination of a flashing strobe light and a repeating pattern of loud horn, buzzer, or bell sounds. Typically 3 blasts, followed by a pause, then repeating again. This pattern is the universal evacuation signal, known as the temporal 3 or 3-pulse pattern. Some notification appliances supply information as well as the alarm signal. One example is a wall-mounted loudspeaker. In some locations, this will also have a strobe light. Private mode notification appliances may be necessary in settings such as hospitals, where not everyone can or should get out of the building right away. When privately notified of the alarm, staff can initiate emergency response procedures that are appropriate for the situation. When an alarm is transmitted off the protected premises, it may go directly to the fire department. More often, however, it will go to a supervising station.
Well, we want to put our system on test so we can do some work on it.
Okay, for how long?
An hour.
A supervising station is a facility which monitors for alarms, as well as supervisory and trouble signals, retransmits the signals to a fire department, notifies responsible personnel about supervisory or trouble signals, and keeps records and creates reports. A property owner may establish a proprietary supervising station to handle alarm and supervisory signals from their own properties. These are often found at multi-building facilities such as schools and manufacturing campuses. Regular inspection and testing of fire alarm system components is essential to maintain system readiness. Inspection alone can spot many problems. For example, an occupant may place cartons or file cabinets in front of a manual fire alarm box, making it unusable. Conducting a visual inspection allows you to spot and eliminate this problem. A lot of the visual inspection process is based on common sense. Look for any change in the component and in the vicinity of the component. Look for physical damage, evidence of water damage, and anything that's blocking the component and preventing it from performing its function. Other problems may only be revealed by a system test. All system components undergo an initial acceptance test to ensure that the system will function as designed. After the initial acceptance test, components will need to be inspected and tested at prescribed intervals according to NFPA 72, National Fire Alarm Code. Tests may be weekly, monthly, quarterly, semi-annually, or annually, depending on the component. If the equipment manufacturer specifies more frequent inspections and tests, follow their instructions. It may be helpful to create a master checklist for every building, which will guide you in scheduling inspections and tests. NFPA 72 also requires you to make sure that everyone concerned, the fire department, supervising station, security personnel, and building occupants are aware that the system is being tested. Supply them with dates and times. If your building has a PA or voice communication system, you may want to use it during the test for additional notification.
Please disregard all horns, lights, and other devices until further notice.
Another solution is to disable the system. Make sure that all concerned parties, such as the fire department and security personnel, know that the system is disabled.
Pull station, please.
Maintain a presence at the control unit for the entire time the system is disabled, and maintain constant communication between that person and personnel working in the field.
First floor, southeast, main lobby.
Keep a record of every component disabled, and use this as a checklist for restoring all components. There have been cases when disabled alarm systems were never restored to service, or only partially restored. Oversights like this have led to property damage, injuries, and deaths. Most tests duplicate or simulate the condition which is being tested for. These are known as functional tests. For example, the functional test for a water flow alarm on a wet pipe sprinkler system is to flow water through the inspector's test connection.
Test valve is closed.
Other tests check electrical, electronic, or mechanical functions within a component. For example, you test batteries under full load, while audible and visible signals are operating. Record keeping is an essential part of any inspection and testing program. You need to create comprehensive inspection forms that cover all components of your facility's fire alarm system. During inspection and testing, follow your checklist so you don't overlook anything, and record the date, time, and results of each inspection and test. Keep the forms on file. Acceptance test results should be kept in a permanent file. Your insurance company may have requirements for how long you should keep other test results. NFPA 72 requires you to keep the records until the next test, and then for 1 year thereafter. The frequency of control equipment inspection and tests depends on whether or not the equipment is connected to a supervising station that receives all three signals: alarm, supervisory, and trouble. If it is, the control equipment must be inspected and tested at least annually. If the control equipment does not send supervisory and trouble signals to a supervising station, it must be inspected weekly and tested quarterly. At the control unit, you will visually inspect the enclosure, lamps and LEDs, batteries, the primary power supply, and fuses. Conduct functional tests on the control equipment to verify correct receipt and transmission of input and output signals, circuit supervision, and power supply supervision.
Reset, advise when clear, please.
Also apply functional tests to any interfaced equipment, following the manufacturer's recommendations for that specific equipment. Illuminate all lamps and LEDs. Disconnect all secondary power and test the primary power supply under maximum load. Reconnect the secondary power as soon as the primary supply has passed the test. If your system has one or more remote annunciators, they should be functionally tested on an annual basis. Make sure the annunciator screen is functional and readable. Most systems will have battery backup power that will activate if the primary power fails. How often you inspect and test backup power supplies will depend on the type of battery. Nickel cadmium and sealed lead acid batteries need to be inspected semi-annually. Non-sealed lead acid batteries should be inspected monthly. The schedule for battery testing varies with the type of battery. More frequent battery testing may be required at a supervising station. With the battery charger disconnected, the fire alarm system maximum load is applied to the battery, and the terminal voltage is measured. Specific pass-fail criteria for different batteries are listed in NFPA 72. The battery charger should also be tested and then reconnected. If your system has an engine-driven generator, a standby power supply, or an uninterrupted power supply called a UPS, specific tests must be performed. Refer to NFPA 72 for details. Some fire alarm systems transmit signals over municipal circuits, interfacing with these circuits at a master box. The master box may double as a manual pull box for the general public. Water flow devices are to be tested semi-annually.
I have a supervisory, garage, sprinkler room. Tamper switch.
Supervisory signal devices, such as valve tamper switches, should be inspected and tested quarterly. Look for leaks, corrosion, and physical damage. Radiant energy fire detectors should also be inspected quarterly. Make sure the lenses are clean and free of contaminants. All other initiating devices should be inspected semi-annually. Make sure heat detectors haven't been painted over or rendered ineffective by new construction. Check smoke detectors for blockage or contamination. Make sure nobody has left in place what was supposed to be a temporary cover to prevent contamination, for example, during construction. Most initiating devices must be tested annually. A few, such as water flow devices, valve tamper switches, supervisory initiating devices, and radiant energy fire detectors need to be tested more frequently. Initiating devices can present the biggest challenge of your testing program, because there are many different kinds, all requiring different tests, and especially in a large facility, there are a lot of them. This underlines the necessity of good record keeping, so that you test every device at the correct interval, and you maintain accurate and complete information for each test. Test extinguishing system alarms only if you are qualified and experienced with these systems, and only if you know how to prevent inadvertent system discharge. Typically, the switch is mechanically or electrically operated, and receipt of alarm signal at the control panel is verified. The method for testing a heat detector depends on whether or not the detector is restorable. Test restorable detectors with a heat source according to manufacturer's recommendations. You are looking for a response within 1 minute. Non-restorable detectors should not be tested by heat. Manually test fire alarm boxes following manufacturer's recommendations.
10-4, go ahead. Alarm received. Pull station, first floor, main entrance.
Smoke detectors require 2 different tests. The first involves using smoke or a manufacturer-approved aerosol to activate the detector. Using a test button or magnet does not meet the requirements of NFPA 72, because part of the test is to confirm that smoke enters the detector chamber. The second test is a sensitivity test to verify that each detector is within its marked and listed sensitivity range. These are required at different intervals, depending on the detector. Check NFPA 72 for details. You may perform a sensitivity test in one of several ways: by a calibrated test method, a manufacturer's calibrated sensitivity test instrument, listed control equipment arranged for the purpose, a setup with the control unit where the detector causes a signal at the control unit when it is outside its listed sensitivity range, or another calibrated sensitivity test approved by the authority having jurisdiction. Air duct smoke detectors and air sampling smoke detectors should be tested following manufacturer's recommendations. Generally, these are functional tests that introduce smoke or aerosol to the detector. Projected beam smoke detectors should be tested with a calibrated card or filter according to the manufacturer's instructions. When an initiating device is a combined smoke detector and heat detector, both elements should be tested independently, following manufacturer's recommendations. If either element fails the test, the unit should be replaced. When a smoke detector has a control output function in addition to its alarm output, for example, operating duct dampers, shutting down power, or recalling elevators, test to verify that the control output works, even when all other devices installed on the same circuit are in an alarm condition. Radiant energy detectors must be tested semi-annually. Perform a functional test on the detector following manufacturer's recommendations. Also perform a semi-annual sensitivity test according to the manufacturer's instructions to verify that each radiant energy detector is within its marked and listed sensitivity range.
Cursory flow water, please.
Sprinkler system water flow devices should also be tested at least semi-annually.
Opening the test valve now, Tony.
For this test to be accurate, water must be flowed through the system. It is not enough to simply electrically or manually operate the switch. This is because a leading cause of failure is a buildup of corrosion inside the piping that can impede the operation of the pressure switch or flow switch.
Chris, I have the alarm, 47 seconds.
Flow water through an inspector's test connection for wet pipe systems and verify receipt of alarm at the control panel.
Closing down the test valve.
Make sure the water flows long enough to activate the switches in all parts of the affected system, such as a standpipe, main flow pipe, or fire pump. Record the time it takes for each switch to activate. If the signal doesn't transmit within 90 seconds, adjustments are needed. With a dry pipe system, flow water through the alarm test bypass connection and verify receipt of alarm. Supervisory signal initiating devices should be tested quarterly. High or low air pressure switches, valve tamper switches, room temperature switches, water level switches, fire pump supervisory switches, and water temperature switches should be tested. Test criteria are found in NFPA 72. With initiating devices, we were testing alarm inputs. With notification appliances, we're inspecting, testing, and measuring alarm outputs to make sure that any alarm will be heard or seen. Inspect to verify that notification appliances are not blocked or obscured. Then you must actually measure the intensity of the sound. Measure the sound pressure level of audible appliances. With the appliance evacuation signal operating, take measurements at locations established during the acceptance test. Record the maximum output and compare the results with the acceptance test reading. Measure the sound pressure level of speakers and other voice messaging appliances in the same way, using the same meter. To determine intelligibility, you must play a special audio recording of calibration frequencies and analyze the sounds with test instruments. NFPA 72 provides specific guidance for this test. Pay particular attention to sound reflective environments, such as painted concrete block walls, which can have a major effect on the clarity of voice announcements. Check intelligibility in all areas where occupants may be, including conference rooms and out-of-the-way areas. Inspect visible notification appliances to verify that they can be seen by everybody in the room. Make sure the strobe is not blocked by shelving, furniture, ceiling-mounted light fixtures, movable partitions, or plants. Run the strobes for at least a minute and verify that all strobes within the viewing area still flash in synchronization. Supervising station systems are complex, and there are many different types. Generally speaking, you will be testing transmitters and receivers of alarm, supervisory, and trouble signals. Test all system functions and features in accordance with the equipment manufacturer's instructions. Consult NFPA 72 for details. At the conclusion of the test, confirm with the supervising station or fire department that all elements of the system have been restored to normal. Regular maintenance of fire alarm systems is your responsibility to make sure the system is functional when needed. Fire alarm equipment should be cleaned as frequently as the ambient conditions dictate. Pay especially close attention to equipment in such locations as HVAC ducts, elevator hoistways, machine rooms, and boiler rooms. Maintenance procedures for fire alarm systems, including service, repair, and replacement, will vary depending on the system and the location. Consult the manufacturer's instructions for details. As technology has advanced, fire alarm systems have become more sophisticated and complex. It's essential to have a program in place for the regular inspection and testing of all system components, initiating devices, control units, notification appliances, and equipment for off-premises transmission of a signal. Fire alarm system components must be inspected and tested regularly. Develop an inspection and testing checklist tailored to the facility and make sure to notify anybody who will be affected that testing is taking place. When inspecting a component, look for any change, including physical damage, evidence of water damage, or anything that is blocking the component or otherwise interfering with its operation. Most tests are functional tests that duplicate or simulate the condition that would activate the system. You will also conduct various electrical, electronic, or mechanical tests of components. Test extinguishing systems in such a way that extinguishing agent is not released. And make sure that notification appliances are not blocked and can be seen and heard by everybody in the area. I know we've given you a lot to remember. That's why checklists and record keeping are so important, to ensure that your program of inspection and testing is effective and thorough. Remember, any part of these systems can unexpectedly fail. It's your responsibility to find and report any failure, so that your system is ready to sound an alarm at any time of the day or night.